We're going to look at the mechanism for nucleophilic substitution. I'm going to look at, in the first instance, a simple nucleophile, hydroxide ions. We know that hydroxide ions are nucleophiles by the fact that they possess a lone pair of electrons on the oxygen atom which will attack the electron deficient carbon atom, which I'm going to show as delta plus here, and the bromine, which is slightly more electronegative, as delta minus. We represent the attack on the carbon atom with a curly arrow showing the pair of electrons from the nucleophile moving onto the electron deficient carbon to form a new bond. At the same time, the bromine will get an even bigger dipole as the pair of electrons on the nucleophile moves in closer, repelling the electron pair from the carbon, between the carbon and the bromine, onto the bromine atom, and this is shown by a double-headed arrow. It's vitally important that your double-headed arrow here comes from the middle of the bond moving on to the bromine. The bromine is known as the leaving group, and because the hydroxide ion is coming in here with a lone pair of electrons, which is now forming a bond with the carbon, I'm going to represent this new bond as an OH, and notice it's lost its negative charge because it's now donated the pair of electrons to that carbon there. Nothing else has changed apart from the fact that the bromine atom has now taken a pair of electrons from the carbon, one that it belonged to itself, one that belongs to the carbon, and therefore you must represent this pair of electrons on the bromide ion, and this is known as the leaving group. And that, in a nutshell, is nucleophilic substitution.